Okay, guys, we're gonna do a problem, and here's the problem. So imagine that we are on top of a building, and there's a person, right? And he's throws a ball, and it kind of um, falls down, and hits the ground. And by the way, this is the ground, right? The ball goes back up, right? And then it falls again, and then it falls, bounce back, and then it goes up, goes bounce back. So it is always bounce from the ground and then up and then bounce again. So you could generalize from this, so like this, right? The ball's trajectory is something like this. And suppose that we focus on the distance here, right? And then this distance here, and then distance here, and a distance here, here, etc., etc. It's gonna go indefinitely. Suppose that the distance from here to here is a. The distance from here to here is gonna be. Notice that the distance is falling with each iteration, right? Of bouncing back because due to friction. So if this is distance from the ground to the tip of the top is a, then here is going to be 2/3 a. From here it's going to be 2/3 a. So this is equivalent to 2/3 a. What's the distance from here? It's going to be 2/3 3a. What about this one? It's going to be 2/3 4a. So we want to know the distance, the sum of all the distance, you know, of a, this one. We want to know the sum of all of it, the distance of the ball from the tip to the ground. So the question is, here's the S. S is the sum that we want. The first distance is going to be a. The second is going to be 2/3 a. Third is going to be 2/3 to the power of 2 a. 2/3 to the power of 3 a, etc., etc., etc. And this is never going to stop. And we want to know the value of S. Now, notice that you could pull a out, right? In which case it's going to be just 1 2/3 2/3 square 2/3 cube, etc., etc. If we set, I don't know, I mean, we could set a to be whatever number that we want, but suppose that we, set a to be 10 or something, right? And that's easily, we need to find the value of this one. Is so So what we're gonna do is we will trying to find the value of S and for a given A. So instead of solving this problem or asking like what is the value of S, as it is right now, let's try to reduce this problem to a more simpler problem. Notice the structure of the sequence or summation, right? Um, the structure of this sequence or summation is more like the following, right? It's going to be like you're dealing with a sequence that is, let's say, let's call it P, right? It's going to be A times R, where R is, in this case, is going to be 2/3, right? A R square, right? Or A R cube. Now, this is going to, for the S series, it's going to continue forever, right? But let's suppose that we terminate at some finite value. Let's call it n. So R to the power of n. We terminate at that point. So if we could find a formula for P, for this sequence, maybe we could just set n to infinity, right? And that would give us a formula for S, right? One way we could do that is suppose that we times R to P. So think of P, but now we add times R to the sequence. What we now have is going to be A times R, A times R cube, R square, A times R cube, etc. And then all the way to A times Rn plus A R n plus 1. Now, if we subtract this series from this series, P minusing P times R, what we have is that, notice that these are cancels, right? Because we're subtracting these two these summations. The like terms get canceled. And what we are left with is the endpoint. And if we pull the P out, and if we pull the A out, we divide both sides by 1 over R. And this is what we have. Now, remember that this formula is the formula for this sequence, right? So, but what we want is a value for S. And in the S case, right, there is no terminating point. There's no Rn, right? There's no endpoint. It's because, well, that's not what we want. We want to have no ending. We want to eventually set n to infinity, right? So we want n to be set to infinity. And notice something. So the for the formula for P, for the summation, notice that our R is less than 1, given that, so our R is less than 1 but bigger than 0. And this is important because notice that if R is between 0 and 1, it follows that R is greater than R squared, right? So, and it's greater than R cube. r to the fourth power, etc. Why is that? Notice that following, right? It's like r, in our case, r is going to be 2/3. Is bigger than 2/3 of a 2/3, right? Which is bigger than 2/3 of 2/3 of 2/3, right? So by this reasoning, if we set n to infinity, r n plus 1 approaches 0, right? So that means that for all we need is to set this n to infinity, and this whole thing is going to be 0. So S is going to be a 1 minusing r n plus 1 minusing r, where we set this thing to 0, and what we have is a minusing 1 over 1 divided by 1 minusing r. So this is our formula to get the value of S, right? So in our case, S is going to be 2/3. So we're going to have a minusing 2/3. It's going to be a minusing 1/3, which is going to be 3a. Oopsie daisy. So suppose that, so this is the result that we have, right? That means that in our original problem, suppose that a is 10. Suppose that a is 10. That means that if we sum all of the length here, it's going to be 3a, which is going to be 30, right? If a is 20, then 3a is going to be 60. Okay. So, yeah, hope you guys like this problem.